So what you were doing before on these types of problems is finding the slope of the secant line. So this was more a college algebra type problem. You're finding the average rate of change between 2 points. So in this case, t equals 0 to t equals 2. You're finding the average rate of change. And then you also did problems to find the slope at any given point. So here I could have found what was the slope at t equals 1. And then that's a calculus problem, and that's basically the value of the derivative at that point. This question is asking you to find the point t in which the slope of the tangent line is 0. So graphing it, I want to find the slope of the tangent line is 0. So graphically, I know it's going to be somewhere between 1 and a half, right? So this point right here is what I'm expecting is when the slope is 0. To calculate it algebraically, what you're going to do is you're going to find the derivative of h. So take the derivative of h, and this saves respect to time, and you're going to set that equal to 0. So if I find the first derivative, I get minus 32 times 2t plus 16. When does that equal 0? Well, that'd be minus 64t plus 16 equals 0. So 64t equals 16. So t would equal 16 over 64. So in this case, it would be 1/4, which from the graph is exactly what we would expect. Now I know you don't have graphing calculators available to you on exams, so you wouldn't necessarily be able to see it. However, keep in mind when you want to find the slope of the tangent line to be 0, that means the derivative is 0 at that point. So if you take the derivative of the function and set it equal to 0, and you solve for the value of t that makes that true, you'll get the value of t where the slope is 0. So I hope that kind of helps relate two different concepts. In the video explanation you were talking about, that talks about the slope of the secant line. That's college algebra. If you do the limit definition, that's going to give you the value of the derivative at any given point. It just happens when t equals 1/4, the value of the derivative is 0. The derivative of h with respect to t is 0, and that's when the slope of the tangent line is 0. So hopefully that clears up anything there. If you have any more questions, please let me know.